Alright, let's tear this one up. This one's kind of a little review, not so much for all of it, but at least A. Let's do A first. A is velocity. I believe velocity is distance over time, but we know distance in a circle is 2 pi r. And in a circle we say period. So 2 pi, the radius is 4 meters, and the period is 2 seconds. So let's just throw that in the calculator. 2 multiplied by pi multiplied by 4 divided by 2 is, let's go 12.6 meters per second. Alright, that's A. Let's see if we can get B done. Force normal. Well, this is going to be interesting. If we look at this ride, we know force normal is the force gravity would be down, and force of friction is up for this because our wall is vertical and the force normal always acts perpendicular. So the force normal is the only force accelerating it. So we could go to the x direction and say sum of the forces in the x equals mv squared over r. And we know the only force is that force normal, mv squared over r. And m, I believe, is 62 kilograms. The velocity, we just did 12.6 meters per second. Don't forget to square it. And the radius of this bad boy was 4 meters. Let's put that in our calculator. My 12.6 was already in there. Oops. Struggling here. It is not still in there. 12.6 squared multiplied by 62 divided by 4. My force normal is, let's just keep it at 2460. Let's go 2461 newtons. All right. Now let's attack C. I need a little room here. Alright, C says calculate the mu static that would be required of the rider to the side of the ride. So the only thing that has mu in it is force of friction equals mu force normal. And if I want to isolate mu, it would be mu equals force friction divided by force normal. And we know from this, sum of the forces in the y direction equals 0, because it's not accelerating that the force of friction, is up, force gravity is down, that equals 0. So I can say that the force of friction equals force gravity. Force of friction equals mg. So everywhere over here I see a force of friction. I can put an mg. And force normal, didn't we figure that out like a last step? 2461 newtons. And my mass was, 62 kilograms. And I'll use 9.8 for all you 10 haters. Alright, so 62 multiplied by 9.8 divided by my 2461. And I get, that's reasonable, 0.20, yeah, let's go 25. 0.25 for a mu. That seems very reasonable. Alright, just for fun, I'm sorry that this is getting all kind of goofed up here. Let's do D over here so I don't have to insert a new slide, which is a pain. Centripetal acceleration, A equals V squared over R. My V, we did that a long time ago, 12.6 meters per second. Let's square that bad boy in a radius of 4. 12.6 squared divided by 4, that should be meters, sorry. And I get 39.7 meters per second squared. Woo woo?